All right, I'm going to try to do this quick example of section 5.2, the coffee problem. So we have a particular professor has noticed that the number of people P who complain about his attitude is dependent on the number of cups of coffee N that he drinks. Okay. And then 8 days they tracked how much coffee, how many people complained. So 8 days. 1, 2, 3, 4, 5, 6, 7, 8 days right there. Okay. So it tells us right here the number of people P who complain is dependent on coffee. So that means the dependent variable is the number of people that complain, and that's dependent upon how much coffee the professor drinks. So what we want to do is we want to put this in not this correlation regression applet. We want to put it in the two variables applet. Okay, two quantitative variables. I'll go here. All right, it is right down here, analyzing two quantitative variables. What we want to do is we want to clear this data out, and we want to cut and paste the data from our problem. We need to click Use Data. Now you can see here we've got the 8 days of data. It produced a scatter plot over here. So what we want to do is we want to click Show Regression Line, and what the applet does is it draws this line of best fit here. This is that line of best fit. Let me go back here. So I have that cut and pasted right into my document here. And this is the line that it came up with. The response variable, okay, that's the same thing as our dependent variable, right? Our explanatory variable, that's our X, and our Y. In this case, it's our N and our P. So this line represents the number of people who complained is equal to 12.54 minus, the slope is negative as X increases, Y is decreasing. So that makes sense, negative slope, times the number of cups of coffee. So all I want you to do is to put that formula right in here. P hat, that means the estimated number of people that complain, 12.54 minus 1.73 n. So this first one says interpret the vertical intercept in context. Well, the vertical intercept happens on the vertical axis. That is my y-axis, or in this case, my p-axis. It's going to occur where x equals 0. So I like to recommend writing this as an ordered pair. So x equals 0, y equals 12.54. And in our case, this is my n, this is my p. Let's translate it. What does n represent? Cups of coffee. When the professor drinks 0 cups of coffee, he gets about 12.54 complaints, P. Let's look here. The professor expects to drink about 13 additional cups of coffee for each complaint. Nope. The professor expects to get a number of complaints to decrease by about 2. Well, that is kind of true, but we want to know about the vertical intercept. This is talking about the slope here. Let's go to the next one. The professor expects to get about 13 complaints if he doesn't have any coffee. Yep. 0 complaints. 0 cups of coffee, 13 complaints. Here's my answer. Interpret the slope in context. What is my slope? Slope is B. My slope is negative 1.73. And I can write that as a fraction. So this is my change in Y, change in X. This is my change in P. This is my change in N. Cups of coffee, people who complain. Okay, so this is people that complain, for every change of one person that complains, cups of coffee, if for every change of cup of coffee, we have 1.73 fewer people that complain. Okay, so let's see what this says here. Professor expects about 13 complaints if he doesn't have any coffee. Now we're interpreting the slope. The slope is negative 1.73. This is not talking about the slope. All right, the professor expects the number of coffee complaints to decrease by about 2. Okay, that's my slope, about negative 2. The number of complaints decreases by 2 for each additional cup of coffee he drinks. That's our answer. It says use the regression equation to predict the number of people who will complain. Well, here's my prediction line, right? That's my regression line. P hat, the number of people that complain, is equal to 12.54 minus 1.73 times the number of cups of coffee. So if we read through this equation here, we want to predict the number of people based on drinking n 5 cups of coffee. We're just going to substitute 5 in for n and evaluate. Y hat equals 12.54 minus 1.73 times 5. All right, the last one's a little tricky. It says, I'll let you do the math for D, but it says how many cups of coffee, that's my n, should he drink so that no one will complain? No one complaining means that P equals 0. So it wants us to solve for n, assuming P equals 0. Well, here's my equation here. P equals 12.54 minus 1.73. I'm going to set P equals 0 here, equals 12.54 minus 1.73 times n. I'm going to add 1.73n to both sides. That gives me 1.73n equals 12.54. To isolate the n, I'm going to divide both sides by 1.73. That reduces out. That gives me n equals 7.248 cups of coffee. So it wants me to round to the nearest cup. Well, if we round that to the nearest cup, 7.2 just rounds down to 7 cups. When n equals 7, approximately, P equals 0. So says he needs to drink about 7 cups of coffee and to have 0 people complain.